Here we are again with a video tutorial for the river Meander Migration Modeling using the iRIC platform. And this is video tutorial number 6, and it is called Calibration Using Smoothing to Calibrate. In the previous tutorial, we calibrated from the year 1942 to 1987. And we stopped in 87 because on the bend in the Sacramento River that we're using, we found that riprap was installed at that time. So it was an appropriate time to have a calibration from one time and stop it when the riprap was installed. Now it seems like we're ready to make a prediction, having quote-unquote calibrated. But are we? I'll tell you ahead of time that often when you try to make a prediction, you learn something about calibration you hadn't known with all the previous procedures that you had taken. Well, if we had enough data, this step that I'm taking right now would not be called a prediction, but would be called a validation stage. A rather typical stage in calibrating. You'd have enough data and you'd have enough history where you'd have known migration, and you pretend you didn't, and you'd predict, and you see how well you did, and see what you learned from it. Nonetheless, for tutorial purposes, I'm going to move on with this step and a kind of a quasi-prediction, and we will continue to learn about calibration and calibration procedures from it. I'm going to draw on many ways. As you see, problems are going to come up, and I'm going to draw on many ways to get beyond the problems that arise. In particular, I will use a new set of parameters, the smoothing parameters, in order to achieve the calibration that I desire. Okay? So, right off the bat, I acknowledge I'm mixing up predicting and calibrating here, but there's good material in this tutorial to introduce you to techniques and tools, and I feel totally justified doing it. Call it what you will. Prediction, calibration, here we go. Okay, at the outset, as you see on your screen there, decisions. We've got to lay out what we're going to do and how we're going to do it. Okay, let's get into iRIC here. Okay. Okay. We'll go to the model just as we left it at our last calibration. Here you see the 1942 channel center line, and it shows the polygons that constitute the erosion field. I've removed the target, the 1987. I've already removed that. And our first step will be to get our 2016 center line. So I won't describe this as I do it. You can follow along. Here we go. Create grid. Now, we've taken our first step and we have our 2016 center line from which we're going to predict. The next decision that comes to us is what conditions are we going to model? We're at least going to use the constraints that we established with our calibration up to the current situation, which you see on the screen there. The background erosion field, which is right here, has a background value of 30, and then we have our restraint on the western side, which would give a value of 5/9. Okay, so that's the active erosion field at the current time. But because we know that riprap was installed, we're going to model the migration with the riprap in place. Okay, so now I'm going to go to our GIS. Here's our bend in question, and I will show you, because I happen to have data show what the riprap is. There's the existing riprap that exists to this day, we put in 1987. Well, you might say, as I did, why don't we just take these files here and import them into iRIC and let them work? Well, the problem is these are line files, and that erodibility grid that we made in iRIC only works with polygons. So I asked myself, why don't I just turn these line files into polygons? Which I did. Buffered polygons. And indeed, these do import right on top of our other polygons. But for reasons I can't explain, they don't work very well in modeling. So we'll have to take those reasons up at another time. Well, then we ask ourselves, what does work? Well, I'll show you what works now. I created a polygon like that, and I created a polygon like that in iRIC. I'm showing it to you in GIS right now, but I created those in iRIC. And ultimately, these seem to work. You see, they give the same information as the other ones, that it's non-erodible once you get there and once you get there. So now I'll go to work in iRIC, and we'll import those polygons into iRIC. We go here and go import erosion fields, and we have to make sure that we're telling it where to get that value. Aha, here we go. You see that one came in. Let's import the other one. Okay, let's look at them a little closer. Okay, there they are. So, these then are the conditions we have to start our runs. Let's get right to it. Okay, as usual, and I do this just to show you because it's something you need to set a habit of doing. I won't skip over this. First of all, we want to set new dates. We're going to start with 2016. We're going to go to 2066. 50 years is a good default time. We always have to worry about our output folder here. And as you know, what I like to do is I like to copy this one, copy the name, I like to paste it, I like to change it. So that I don't confuse it with these other versions here, I'm going to call it version video 1. So that's the video 1. Okay. Make sure that that's where it's going to go. The video 1. That's where output's going to go. Ready for our first run. There it goes. Running quite quickly. Now I immediately look at mine in GIS. And we can turn this off. Turn on the background just so we know that. And now we'll import the one that we just ran. There it is. And again, I like to copy this name so that I know exactly what I'm dealing with. And there we have, can't quite see it yet. Before I do anything to check it out, I rename it. There it is. There's the whole thing. And then give it some properties. I like to reserve blue for observed. So we'll pick some other colors. There it is. That's our first run. Well, you notice a number of things here. It's wiggling around, and it cuts through the riprap. So this is where I will show you how to use the smoothing in our predictions. We know that it shouldn't cut through riprap like that, and we go to Calculation Condition, Setting, Smoothing. So we have filter spacing of 3 and a smoothing distance of 4. But if we change this to 2, we change this to 5. Okay, now make sure we change our output. Copy the name. Okay, that's our output. And we'll run this with the new smoothing. So it says the solver finished calculation. And I don't see, that's the old one. I don't see where it finished it. So we have a problem. Even though I wasn't able to see it, it did run, and I'll now go get the output. There it is, video 2. Let me go back and save that name. Before I do anything at all, rename it. Stand a chance of finding it someday. Okay, now we see some pretty funky stuff here. First step I take when I see funky stuff like that in the code, in the runs, is to go to the conditions here and I turn off the calculate u sub f. I won't discuss why right now, but we'll turn it off. Okay. And we'll make another folder. Video 3. Okay. Running it this time with the u sub f turned off. runs. And we'll bring in our output. Video 3. Doesn't work. Okay, well, we seem to have solved a problem here by turning off the use of F. Now, I will let you know that I went and looked at the other way of looking at it here. And although we seem to have resolved some problems down here, we haven't completely resolved these problems, and we have an enormous problem. So although it's somewhat okay in this area, we need to tweak it again. Okay. The next way, when we see something like that we tweak it, is by changing the time step for the prediction. It's pretty characteristic if it does those big loops, that changing the time step from 1 year to 1/10 of a year will do it. Okay, now we have to change our output. We'll go on to video 4. Now you'll see it takes longer to run because it's running at 1/10 of a year rather than a year, which is okay. When it finishes, we will bring it into GIS and see how well it did. And we'll also look at it in iRIC. I go through some of these very tedious steps because I hope you can improve on them. I think much of this needs to be automated, but that waits for another time. Okay. Okay, a little confusing here with the different colors. This was video 1. I'm going to turn that off. Okay, I'm going to turn this off. Go behind that. So the green is having used a time step of 1/10. Seems to work similarly, even maybe a tiny bit better here than the previous one. Now we need to test it back in iRIC. And we don't see any curly cues. Okay. So where are we now? We return to look at our results here. And we found that we are stable and not getting curly cues, but we still have the problem that the predictions are cutting through the riprap. So that suggests that we change the smoothing some more. Now, as you can tell, this is a long and tedious process. You can do as many as 50 or 100 runs in a day. And zeroing in on what works. And I will get back to my model here. And I tried a couple of different conditions, and what I found was that if I change the smoothing to filter spacing of 1 node, smoothing distance of 4, and then I went back to my coefficient of friction and I changed it to 3. I did this in a number of steps to get to this, but now we'll change our output. It's number 5. Okay, now let's run it. I will begin to bring it up. There, you hear it's finished in the background. 5. I open it. There we go. Got all the good names there. There we go. Okay. So, let me turn off the previous calibrations. That's the first one we tried. That's the next one. And now we're at this. Let's look and make sure that the entire thing is workable. No curly cues. Back to here. Okay. This ends our tutorial on calibrating while doing a sort of semi-prediction. And I'll give some summary here. There's an enormous amount going on in this tutorial, as you are aware. In some respects, it looks like the train got off the tracks here. We pretty much did whatever we had to get something that we considered a reasonable run. And I think this tutorial raises a lot of questions. Like, is it reasonable to adjust so many things to get the channel to behave in a way that we think is reasonable? I will leave that to us to decide at another time. Recall, I had said all models are wrong. Some are useful. And I find this useful. For example, when you look at the output here of this prediction, you see that between 2016 and 2066, the channel tends to move in this direction. Well, that's a prediction. It's questionable because it looks like the channel had been moving this way. But also, recently there was a cutoff. So that is an area to really be concerned with. Huh? It also shows that this has migrated in this direction and wants to migrate in this direction. I think that's an accurate prediction and something that we can think about and important to think about. We also have this area here, and that may indicate that there's extra pressure on the restraints in this area. So again, to quote the other thing I did that I said about models previously, and that is that models don't predict what's going to happen in the future. Models help you think about what might happen. So I call this one useful. I call them useful. But this tutorial certainly shows you how much experience you need to just keep plugging through all sorts of issues that arise. If this were a project where I was doing, I would now use the information that I learned in this quote-unquote further step of calibration and go back to my previous calibration and see how well the values worked there. So, to summarize, there are lots of knobs and adjustment screws we used. First of all, we turned off the U sub F. That's a component of the velocity that's very small, less than 5%, but it often causes calculation problems, mathematical problems that don't have to do with the modeling. And so turning it off maybe loses 5% of your accuracy, but it often makes the code run when otherwise it doesn't. One of the clues is if you start to get an overly wiggly channel, or channel starts to cut back on itself, then turning off the U sub F is one of the first things to do. Likewise, we set the modeling time step to 1/10 of a year rather than a year. Again, if the model starts to do some serious donuts on top of itself and really curling around, trying to set the time step to 1/10 of a year is usually quite helpful in iRIC. Okay? Then we worked with the smoothing algorithm. And in this case, when it seemed like the channel was cutting through restrictions that should be impervious, it's likely that smoothing is causing it. So, and finally we used our coefficient of friction again to help get the results we wanted. Okay, as I said, now there's a lot in this tutorial that merits discussion, which we will hold for another time. At this point, I just wanted to lay out and show you some of the complications that can arise, and show you the tedious process of iteratively trying various things, and also showing in particular how you deal with certain kinds of problems when they come up, and what particular little tweaks and screws and knobs you use to take care of them. As always, thank you for watching, and if you have any questions, please do contact us.